Hey there, section 1, and anyone from 2 or 3 that wants to see me walk through this Blackjack Simulator example one more time. Today in class, we didn't introduce any new material, we just practiced a little bit with what we already know. And I decided to do this because we didn't have class yesterday due to the snow. And so the example we used today was a Blackjack Simulator, a very simple Blackjack Simulator where we were looking at a very specific question. If we shuffle a deck of 52 cards, how many times are we likely to pull a blackjack on the first 2 cards that we draw? And so to pull a blackjack, we have to pull an ace card and a 10 card. And in blackjack, a 10 card is a jack, a queen, a king, or the 10 card itself. And so what we started out by doing is taking a look at this deck class that I would encourage you to try moving through this material on your own first. I'm going to move through this fairly quickly. And where you get stuck, feel free to follow up in this video to follow along with. So in this runner, what we're seeing now, that you're going to see in problem set 3 as well, is that we can change the instance that we're working with when we start up this GUI. So here we're saying we're going to create a new instance of the deck class, and that's what we're going to use to draw our GUI. And so the deck class has a few methods. It has a draw method, which will return a card to us. It has a shuffle method, which is void. It returns nothing. Its effect is shuffling the deck of cards, and a size method, which will return an integer, which is the number of cards currently in the deck. So we see that a deck starts out with 52 cards. We draw the first card, and we get an instance of card that we're now working with in a new window. And now that we have an instance of card, we can call methods on it. We can say, hey card, give me your string representation. And we see that we've pulled the ace of hearts. We can ask a card, are you a 10 card? That's false. Are you an ace? That's true. And we can see now that we've drawn one card, we now only have 51 cards left in our deck. We can draw another card. We can check its string. It's a 2 of hearts. So we can see that we're not in a shuffled deck. If we want to shuffle the deck, we can call the shuffle method. That returns nothing. And now when we draw a card, we'll see that we're drawing a card at random. So the jack of hearts, we drew that time. The 7 of clubs, we drew the next time. And we can see that we're down to 48 cards. And so what this little instance UI gives us is the ability to interact with instances and code as if we were writing the code and calling these methods in code, but it gives us a little graphical user interface for calling these methods and playing around with it on our own. And so the names that you're seeing here, like D0 is an instance of deck, this D0 variable name is kind of made up just to say that this is a variable that we can reference, and the way that we would, if we had a reference to a deck named D0, the way that we would call these methods on it are by saying D0.drawCard. And when we draw a card, we see that we get an instance of the card variable, and maybe we assign that to a variable named C4. And if we had a variable named C4 that stored a card, we could say C4.getString, and that would return a string that's just a value, or a Boolean that's false for calling whether or not it's a 10 card. So what we can do is you can actually use this interface to get a sense of what are the lines of code if I had a new deck that I could work with, that I could run and use in my own Java code. So the first thing we did is we looked at this card class, and we can instantiate, instead of deck, we can instantiate a new card here. And let's say we wanted to ask for the 9 of hearts. And so this will instantiate a new card whose rank is 9, the 9 card, and its suit is hearts. And we see that we run this project again. We've got a card instance now. We're not working with a deck anymore. We're working with a card, and we can see that it's a 9 of hearts. And there's no way to get another card out of this because all we can do is work with the card that we instantiated here. And so we took a look at the card class and asked, where is there a bug in this class? And it turns out there's a bug, and this is 10 card method. We could prove that bug by saying, 10 should return true when we ask the card if it's a 10 card, but so should 11, which is the rank that corresponds to a jack. So we try this out. We see that if we get string of a card whose rank is 11, it's the jack of hearts, we should be able to ask, is 10 card, because in blackjack, 10, jack, queen, and king are 10 cards. True or false, are you a 10 card? And it should return true, but it returns false. And so if we go and look at y, we see that it's doing an equality check on whether the rank is equal to 10. But the check we want to enforce is whether the rank is greater than or equal to 10. So that 11, 12, and 13, which correspond to jack, queen, and king, will return true. So we can try this again with our jack. We see that we've got the Jack of Hearts still, and now is 10 card will return true because we've fixed our logic here in this Boolean comparison here in our card.java file. So now that we've got a working card implementation, we're going to jump over to the Blackjack Simulator itself. So if we try interacting with a new instance of the Blackjack Simulator, what we'll see is that Blackjack Simulator has only one method defined on it, shuffle deck. It gives us back a deck that we can start working with. If we call shuffle deck multiple times, we see that it will return to us multiple new instances of a deck. So every time shuffle deck runs, it's creating a new instance of a deck and giving it back to us. Let's go take a look at shuffle deck's code. So if we open up Blackjack Simulator.java, we'll see shuffle deck is a method that returns type deck. And all it's doing is instantiating a new deck, assigning that instance to a variable named deck, lowercase, and then returning that straight away. It turns out this isn't a shuffle deck. If we want to shuffle the deck, we have to say deck.shuffle, and this has the effect of sending a shuffle message or calling the shuffle method on the deck that we're working with, and then we're returning it. So we can try this out. We can see if we begin with a shuffle deck by saying, hey, Blackjack Simulator, I'm going to call your shuffle deck method. You give me back a deck. I draw a card, and the card that I drew was an 8 of diamonds. I draw another card, and the card that I draw is a 2 of diamonds. So this looks pretty random to me, and we're good to go. So what we want to do next is add a method that will run a simulation of drawing 2 cards from the top of a shuffled deck. So what we're going to do is we're going to add a method that is void, and its name is SimOnce. It has no parameters. And so what we do in SimOnce is we say we're going to work with a local variable that's also named deck. But rather than repeating this code up here, we're going to reuse this shuffle deck method by saying this.shuffleDeck. So we're calling the shuffle deck method on ourself. We're saying, hey me, call my shuffle deck method. This was similar to how with BB8 we said, hey me, turn left 3 times, or sorry, turn right 3 times in order to turn left. So this is saying, hey me, call my shuffle deck method. This returns a deck because its return type is deck. And so we take the shuffle deck, and now we have a local variable in SimOnce that's named deck and is a shuffled deck of cards. So the next thing we need to do is say we're going to declare a local variable named card0, and card0 is going to be the result of drawing the first card off the top of the deck. We're going to do the same thing with the next card. So card 1 is the result of saying, hey deck, draw another card and give it to me. And remember, these are just the same as those methods, buttons we were pressing on the user interface. After we had called shuffle deck in the user interface, that gave us an instance of the deck method we could call those methods on, and we called draw twice on our own. In fact, if I were to run this now, rather than calling SimOnce, I'm going to call shuffle deck again, and let me try and get this code to show up. So I'm going to call shuffle deck just like we're doing here on the first line of SimOnce. That gives us back an instance of deck. This happened here, but rather than D0, we said we're going to give the name of the deck that shuffled deck returns a name of deck. And then the same 2 things that are happening here, we're assigning the result of calling deck.draw. So that's like calling this button or pressing this button here, which calls that method, which gives us back a card, and then calling it again. And so now we have 2 instances of a card that are exactly what we did down here. So this is an example of how, by sort of working with this user interface, we can start to see what are the lines of code we would need to call in our code in order to get these results. So in order to draw 2 cards from the deck, we needed to say, hey, instance of the deck, draw a card, and then draw another card. And then we need to assign the cards that we drew to local variables so that we can reference them later in our method. So now that we have these 2 cards here, we want to print out what are the 2 cards that we drew. And so we can use our handy system.out.println method. And we're going to print out card0. We're going to call its getString method. This returns a string, and we're going to concatenate that with an empty string and say card1, give me your string as well. And so now when we run this code, we'll see that after we draw 2 cards, we're going to print them out in the console, the ones that we drew. So SimOnce returns nothing but prints out queen of spades and king of hearts. We can sim again, and we see that we pull out a 6 of clubs and a 4 of clubs. Try simming again, it returns nothing, queen of hearts, 8 of spades. Wouldn't it be nice if the result of calling SimOnce returned to us true or false, whether or not we drew blackjack in that run, that simulation run? So what we'll do is we'll change the return type of SimOnce to be Boolean. And after we print out whether or not we drew, or what the cards that we drew, what we'll say is if card 0 is an ace, and remember the and sign allows us to join two Boolean conditions and will return true if both sides of it, if both Boolean expressions on the left-hand side and the right-hand side are true. So if card 0 is an ace and card 1 is a 10 card, then we're going to do what's in these curly braces. And so this is an if statement that will run what's in these curly braces if these two conditions are true. And all we're going to do is return true because this means that we drew blackjack. Otherwise, we're going to return false. And so now, when we call SimOnce, after we draw two cards, we're going to check, is the first card an ace, and is the second card a 10 card, which could be a jack, a queen, or a king as well. If so, we're going to return true, otherwise we're going to return false. Turns out, if you think about this for a moment, we're missing an important case here, which is what if the first card we drew was a 10 card and the second card we drew was an ace? So we're going to add another condition to the else body of our if else and say if the first card we drew is a 10 card, so we're going to call the is10 card method on card 0, and card 1 is an ace, this is the other condition in which we've pulled blackjack, and we'll return true here. So this is the other way we can make blackjack. We've covered both cases. Otherwise, if that's not true, we know we haven't pulled blackjack because we pulled two cards that don't sum up to 21, and we can return false in that case. So we save this, and we try running our program again. So now we can say SimOnce, false, we did not pull blackjack, false, and we can keep running our program. And it turns out this is pretty tedious because we have to pull a number of cards before we actually reach a blackjack case. And we're trying to figure out how many times on average do we need to pull two cards before we, on a random shuffled deck of 52 cards. So remember, each time we press this method call button, we're shuffling a brand new, fresh 52 set deck of cards, and the computer is checking whether or not we've pulled blackjack. And it turns out we just did. And we pulled an ace of clubs and a 10 of spades. It looks like that took about 20 tries or so, give or take. So now what we want to do is, rather than having to press that button that many times and call that method over and over again manually, we learned last week about looping on Thursday, so why don't we write a loop that causes this SimOnce method to run many, many times. So we'll do that by starting out with a new method named SimMini. It will be a void method with no parameters. And in SimMini, we're just going to have a very basic while loop. So we say while I, which is a variable we initialize that's an integer to 0, is less than 10 times. So we're going to run this loop 10 times. We have to remember that after we do whatever it is we do in this loop, we're going to increment I by 1 and then go back to the top of the loop, run whatever we want to repeat 10 times, increment I by 1. And so what this has the effect of doing is, if we think through this step by step, and I'm just going to go ahead and plug in what it is we're going to do 10 times. So we're going to say SimOnce 10 times. So now we initialize I to 0 when we call SimMini. 0 is less than 10, that is true, so we enter the while loop, we run SimOnce once, we increment I by 1, so I is now 1. We reach the end of that while statement, we go back to the top. I is 1, so 1 less than 10, true. We enter the while statement again. We run that SimOnce method. We increment I to 2. 2 is less than 10. 3, 4, 5, 6, 7, 8, 9. 10, when we go from 9 to 10, and so I is 9, we've run that sim for the last time. I increments to 10, we go back to the top. 10 is no longer less than 10, so we stop looping at that point and we jump past the end of the while loop. If we run this code, we should see when we call SimMini, we return nothing because it's a void method, and we've got 10 trial runs over here on the right. And it turns out we did pull blackjack in those 10 runs, an ace of club and a 10 of spades. All right, that's pretty cool. What if, though, we didn't want to have to look at those results in order to count them? What if we wanted to count the number of times we pulled blackjack and let the computer count for us? Computers are good at counting. We should let it do its thing. So what we're going to do next is we're going to set up a new variable which will hold the number of times in which we pulled blackjack. We'll name it count and we'll initialize it to 0 because when this method begins, we have not pulled blackjack any number of times. We want SimMini to tell us how many times it pulled blackjack, so we're going to change its return type to be integer. And now it's telling us, well, we must return a type integer, and so we know if we're going to store the number of times in which we hit blackjack in the count variable, why don't we just return count when we're done? And the only thing left for us to figure out is how do we increment count each time we pull a blackjack. So if we think about our SimOnce method, we know that it returns true or false because it's a Boolean method based on whether or not we've pulled blackjack. So we programmed the logic here to say if we pulled a blackjack by pulling an ace first and a 10 second, or by pulling a 10 first and an ace second, we're going to return true in those cases. Otherwise, we're going to return false. And remember that when we return a value, it has the effect of replacing the method call with the value itself. So this.SimOnce will either be replaced with true or false when the computer gets around to running this code. So we can do two things with this. Well, the first thing we could do is we could say, well, why don't we just store the result in a Boolean variable named is blackjack and say the result of simming this once time through is going to be stored in a variable named is blackjack. And so if this is true, if we did pull blackjack when we simulated, is blackjack will be true. If we didn't, is blackjack will be false. And then we know we can use an if statement to check if we pulled blackjack, then we want to increment count by 1. All right. If we did not pull blackjack, we will not increment count. So each time we run this, we're only going to increment count if we did successfully pull blackjack in our SimOnce method. Turns out we don't even have to actually declare a local variable named isBlackjack to hold the result of SimOnce, because the result of calling SimOnce is a Boolean. We can just use it wherever a Boolean is expected, and we know that a Boolean is expected within these parentheses of the if statement. And by sort of a substitution rule, because we're assigning the result of this method call to a variable, and then we're using this variable later on, but we're only using it in one place, we could just as easily take this method call and use it directly instead of storing it in a variable. And so this has the effect of saying, if the result of calling SimOnce is true, then we're going to increase count by 1. If the result of calling SimOnce is false, we're not going to increase count at all. We're going to skip right past that and just move on with the next iteration of this loop. So we can now run this code, and when we run it, we can say SimMini, and we see that we pulled blackjack 0 times that run, 0 times that run, 1 time on this next run. And it's a little bit off the screen. Actually, no, it's right here. We can see that we pulled the ace and the king. That's kind of cool. The last step that we wanted to sort of move through on this hands-on is, well, why don't we make it so that we can run as many times as we want? And we don't hard code this 10 number in here. What if we wanted to change the number of simulations we ran time and time again? We can do that by giving SimMini a parameter, and by giving it a parameter, we're allowing whoever it is that calls SimMini, which is us when we press that button in the user interface, we have to provide that extra piece of information that says how many times we want this loop to run. So we're going to create a parameter. It'll be an integer, so we give it some number, and that number will be the number of times we want this loop to run. And currently we're just running this loop 10 times. Rather than 10, we'll say whatever someone gives us as a parameter named times, that's how many times we're going to try looping this simulation over and over again. So we save that, we run again, and now we see when we go to call SimMini on an instance of Blackjack Simulator, we have to provide an argument, which is the number of times we're going to run this code. So we could provide 10, just like we had before. We see that we've pulled blackjack 0 times out of 10. We could just as easily change that to 100 runs, and we'll see that there's even more off my screen. 4 out of 100 runs, we pulled blackjack. We could give it 1,000. 54 times out of 1,000, we pulled blackjack. Well, what if we just ran this quite a few times and tried to use the law of large numbers to pull out the statistical probability? Before I do that, what I'm going to do is comment out this print line so that we're not going to print out every single 2 cards that we draw, because that actually slows down the simulation quite a bit. And let's say we run this program 10,000 times. Actually, that's not too many for a computer. Let's run it 10 million times. So we simulate, we call the SimMini method on an instance of Blackjack Simulator with 10 million as the argument to the method. And what we do when we call this is we're going to see that the computer is going to work hard. We're beach balling. The computer's so happy right now. It's on vacation. It's loving its life because it's going and it's computing 10 million times over this process. And this process, if I can remind you, is we are shuffling a deck of cards, 52 cards. We're drawing the card off the top, and then we're drawing another card off the top, and we're comparing whether or not those 2 cards are an ace and a 10 in either order. And if so, we know that we have blackjack. If not, we don't have blackjack. And we can see that 482,000 times, in just that time that I was talking, the computer ran 10 million simulations, and 482,000 times it did draw blackjack. And just to put this into perspective, 10 million is the number of people that live in North Carolina, and then 3 million more, right? So if you can imagine giving 10 million decks of cards to everyone in North Carolina and then a few million people in South Carolina, asking them to shuffle them, drawing 2 cards, and telling you whether or not they pulled blackjack, that's what we just had our computer do in the time that I was talking. And what's cool is when we run the simulation 10 million times, we see that we get 482,939, which turns out to be like 4.83%. If we compare that to the actual mathematical probability that we could compute using formulas and statistics, we're actually just about spot on. The mathematical formula using some combinatorics is in the slide deck. But we see that if we try and prove mathematically what are the odds of pulling blackjack in a perfect world, it's 4.83% of the time we're going to pull blackjack. And in our simulation, where we ran 10 million trials, we actually got 4.83% right on the nose. And so by running a simulation this many million times, we start to hone in and zero in on the statistical numbers that you would expect using math to prove it. This is just one example of how we can use loops to run some really powerful stuff. And in this hands-on, we got to see some method definition, some local variable definition, method calling between classes, method calling between the same class. A lot of cool concepts were covered, and hopefully you made your computer happy and ran that 10 million times as well.